Hi, I'm Inder Rana. I'm a principal Azure technology specialist for data analytics. So what that means is I translate to a technical architect in simple terms. I focus on the data platform, data components of the Azure platform, and Fabric is one core product out of from that particular stack. Um, so Greg and I have developed this a sample GitHub repo with a real world data set with 250 million rows. It's a healthcare domain data set. It's a CMS Part D prescribers by provider and drug. So what that means is when any Medicare or Medicaid patient goes to a doctor and he prescribes certain medicines, that is recorded in this data set, and CMS makes that available for research purposes as an open free data set, public data set. Um, so that's what I will walk through. Um, Greg, introduction for you as well.
Sure. Yeah. So Greg Beaumont, I am on Ender's team. We're both in the healthcare vertical. I've been with Microsoft 8.5 years, and I've been in the healthcare vertical since it was formed back in 2017. Prior to that, I was in the consulting network for many years. And it's fantastic to be working with our healthcare customers. And even if you're not in healthcare, this demo should hopefully give you access to a large scale end-to-end Fabric solution that you can use for testing, demos, or whatever those needs might be.
Thanks, Greg. With that, I will just move on to the first slide. The slides is only two or three, and after that, I'll just do a live demonstration of the setup. Um, so it's easy to use demo with large volume of real world healthcare data. It's 250 million plus rows. That's the kind of nicety of this demo, and easy to deploy. We can set up like in any environment where you have a Fabric enabled workspace. I have used F64. I've also used F2. If it works, it takes a little bit longer. So it should work in the Fabric trial SKU as well. Um, and 10 minutes to configure. I will do the setup right in the session today, and I'll kick off a pipeline to hydrate the data. It takes about 20 to 40 minutes. If you're lucky, we should be done with that pipeline before the end of the session today. And after that, I'll be passing it on to once I kick off the pipeline for loading of the data. I'll pass it on to Greg, and Greg will kind of go over the remaining steps, and then he'll hand back to me once the pipeline is complete. Um, so the idea is Microsoft Fabric is a complete data platform. It's SaaS, so all the components are there. You don't have to put in any effort. Once you get a workspace, you have everything available. So it's all geared towards time to value. If something used to take 6 months before, we can get it accomplished in 6 weeks. That's the kind of a value prop of Fabric. Um, and this was, we built out this repo a year ago. At that time, there were quite a few manual steps of downloading the data set from the CMS website, uploading it to the Fabric was manual. And then also one big distinction was we only used Lakehouse at that point in time. In Fabric, if you're familiar, I'm assuming that you have Fabric background, so I'm not going to the basics of Fabric. In Fabric, you have warehouse as well as Lakehouse. There are two kind of variations of data of the warehousing. I will call it. And in the older version, we only had Lake House because the key was this Power BI Direct Lake mode, which is very efficient way of hydrating your semantic models or getting very performant reports. It was only available in Lake House at that point in time. But now we have updated our solution. So the quite a few updates here. All the steps of downloading, uploading are now automated using Fabric Spark notebooks. And then we have given two options. We have included, in addition to Lakehouse, of that Warehouse as well, because Warehouse is meant for more of a skill, right? If you're very much of a T-SQL person or a SQL person, um, and don't want to, delve into Spark technology, and that's where Warehouse comes in handy. And then second thing is it's again an architectural pattern. In Fabric, you can mix and match different pieces. So what I'm showing over here is medallion architecture. So bronze and silver are implemented by using a Spark notebook. And then for the gold Lakehouse, we still use Spark, but if you prefer of more of a the code layer in a warehouse, which is, which is the common data like skill set for consumption, SQL. If you just want to be SQL heavy, at that point we have Fabric Warehouse option as well, and that's where I'll pass the ball onto Greg to talk about the option B. But both of them can be set up pretty easily. Okay, with that, um, I will kind of move forward. So let me show this is the GitHub repo. Before I even go into the setup, I will just kind of show you a glimpse of what the end product looks like. So I have a Fabric workspace over here. I just built it out. I did a dry run last night, and I have a lake house in that created and populated. So these are the bunch of tables in here. This is the CMS raw. So the first step when my pipeline is set up is to download these CSV files from the CMS website. And then the second step is to build out a table over here, which is the CMS provided drug cost. So this is a flat table. So we converted the CSV files into Delta Parquet table. This has about 250 million rows. So that's a flat table. So that forms your silver zone. We did some minor transformations like combining some fields together to give a composite column, data type updates or changes, conversions. So simple things we did. And then the third step of the demo of the setup would be to build out this star schema model, where this CMS provided drug underscore cost underscore star is your fact table, and the remaining top are dimension tables. So these are the star schema model is very important for Power BI. So that's the ideal kind of a way to model your gold layer. So that's what the third layer looks like, gold layer, and lastly, end result is you build out a semantic model on top of it, and then you have a report, right? And just to give you a glimpse here, I do have a few reports which I use Power BI Copilot to create the reports. Let's see if which one comes up first here. I'm just giving you an example here, showing what the end product looks like. After that, I will just get into the setup. And please feel free to post any questions in the chat message at chat window. Greg will help answer, and when he's presenting, I will do the same as well. So a handful of reports, all of them were pretty easy to create because we have a nice semantic model. We execute commands against it to create these reports. It's drug cost analysis. Um, the data goes back to I think 2012 or 2013, so it's showing the total drug costs have gone higher up. So this is the end goal. So I will not spend too much time in here. I will just switch to at this point to my Fabric workspace, which is brand new. It has nothing in it. So the idea is to kind of set that up right now in front of you. Um, so first thing I will do is I'm in the data engineering persona. So I'm already in the data engineering persona over here. So first thing I will do is I'll create CMS underscore lakehouse, create. Um, So now I have an empty lake house. At this point, what I will do, I'll go to my GitHub repo. So the idea is to walk through these steps. So I just executed the first step one, create lake house and set up smart. I just created the lake house, and then I have to set up the Spark notebooks. After that, I'll set up a pipeline in using this option, which uses Spark all the way through and loads the data into Lakehouse. And after that, I will just hand it off to Greg, who will show the 2B option or talk about the 2B option of using Fabric Warehouse for the code layer. Um, so every step is documented. We even have a video. So whatever I'm walking through, you have reference in here as well, in addition to the video being recorded right now. So let me just jump back to okay, no, so I have to set up the notebook. So what I will do, there are three notebooks here. The number is 01, 02, 03. So one by one, I'll need to download those. So I just clicked the notebook link. So in my GitHub now repo, I have this GitHub, this notebook, Spark notebook loaded. And as you see, a notebook has quite a bit of description. It explains what it does. So what I need to do is I need to click this download raw file. So one by one, I will be downloading. I need to download all three files for Convenience, I just for the demo purpose, I just downloaded these three right here last night. So I'll just use that. I will not download in front of you. But that's how the process goes. You click that little download button and you have the notebook available. And what you can do is you go here. I go to the home page on my workspace. I'm in the data engineering persona. So it's import. I click new notebook from this computer. At this point, I will go and pick up all these three notebooks. And it's pretty quick to import these. I'll one by one um, open these notebooks, and there's a minor update I need to do to be on the safe side. Um, so when I have this notebooks uploaded, the lakehouse information is embedded in it. So it's better to remove and add the lakehouse reference to this particular workspace. So I will just go ahead and say, even if it is the name is the same, I have many, installations of this thing. So the name might not represent the one I want to use. So I chose the Lakehouse without schema, though both of them are supported. Both way it works, we have tested. I just prefer using the Lakehouse without schema because that's generally available. Lakehouse with schema is in public preview at this point. So I just said add, and this is my topmost link. This is the CMS Lakehouse in my current workspace. So I'm assigning, and this is notebook is now configured properly. So just to give you a little walkthrough of what this does is it just creates the CMS raw folder in the Lakehouse file section. Um, and then I will just switch to show what it is here. CMS makes this metadata JSON file available for all the data sets they have. So I have, just implemented the code to parse this JSON file to kind of figure out all the files for this particular relevant data set. So the benefit here is that as they add more files, you don't need to make any code change. So that's what it is doing. It is just trying to um, this Medicare Part D prescribers by provider and drug. That's the name of the data set. As long as they don't change, we pick up all the files in the CSV format and we download them to the file section. Um, and also one thing I'm doing is there is one file, separate file for each year. So I'm just doing some code, regular expressions to figure out the year. And that's how I'm naming the file based on the year. And that year is used in the subsequent step when we create the silver zone table, which is a flat table with all the records. Um, Okay, so that was the first notebook. At this point, I'll switch to the second notebook. Um, I'll do the same. Um, Most likely your lakehouse name will be different. Mine is same, but I'm still executing the steps here to attach to the appropriate lakehouse, my second files. So what this file does is it takes those CSV files and builds out the lakehouse tables. Lakehouse table. And here it is kind of just showing, it's reading up all the files. Then it's adding a year column based on the file name. So that like this is just a previous run and it retains this information. So if you look through this thing, um, this data frame in Spark has the year column. And then at the end over here, we are doing some more manipulation. Like for example, prescriber city state, we are creating this new column based on the existing columns. At the end, we just write out to this to a flat table. So that's your silver zone table. I will close these out, um, all of these, and then I'll go back to the home page here. I'll just open the, oops, I'm sorry. I hope I fixed it in the correct. Um, I'll just open this one just to make sure. I might have done this update of the lake house on the other workspace which had the report. So I'll just do this one more time to be on the safe side. This is the second one, and I will just say here CMS Lakehouse. Okay, and now the third one is this one. Create CMS star schema tables. On add. And one thing I just wanted to point out over here, it's pretty easy to use SQL in Spark as well. So it's a combination of Python and Spark code. But if you look through the code carefully, it's all SQL statements. So that's the beauty of Spark, that you can use SQL quite a bit. It's a slightly different flavor. It's called Spark SQL. So what I'm doing is I'm kind of running some SQL queries and from the on the flat table, and based on that, I'm populating my dimension and fact tables. So that's the third one. So I will just do one more thing here. I'll just do this lake house association one more time on the first file as well, just in case I made a mistake. And we expect to, as time goes by, improve this, if there's a way to kind of fix this thing, make it easier, we will do that. But right now, this is how it is. Um, so we are good on this thing. Now we have the first file open. Um, And what I'm going to do over here is I'll say add to new pipeline. Um, so I'll just say um, populate or load CMS tables datasets. So so far I have just have the notebooks ready, but what I'm doing is I'm creating a data factory pipeline at this time, which is just an orchestration that run the step one, step two, step three, step one being the first notebook, step second being the second, and the third the same way. So I'll just have a notebook over here. I'll just copy, or like I'll just click notebook. So I have three of them. So this will be download CMS data. That's the first step. And let's look at the setting. It already is configured because I started creation of this data factory from the first notebook. I'll go to the second one. Um, Create CMS table. That's the second step. And this will be the second notebook here. And then the third notebook will be load CMS star schema tables. And I'll switch to the settings and pick the third one. And it's important I just say on success, and then I just save my pipeline. Um, the first step is downloading. Second one is reading the CSV, creating a flat delta Parquet table with 250 million rows. The third step is building your code layer, which is star schema tables. And with that, I can just kick it off. And this notebook runs non-interactively, so that just means I can just close it out. It doesn't matter, and I can walk away. And if I go to the monitor grid, that will be another way to monitor the execution status. It shows up over here. I can filter by data pipeline. As you see, there are a lot of them uh, executed over the last few weeks. And this was the one I ran successfully last night, and this is how it looks like once it's complete. And it took about 8 and 15, like 21 minutes to get the data into the lake house. If things go well, I should be able to kind of showcase you that in the call today. With that, I will pass on the ball to Greg Beaumont. Greg, are you there?
All right. Yes, I am. How's my audio?
Very
Am I
good. So
good?
one thing, sorry, I forgot. Our product group kind of asked us to kind of call out that there is a first party solution too about the CMS claims. That's different. We should just, make our users aware. So if you want to kind of just call that out as well.
Absolutely. Yeah, yeah. So when you read about healthcare data solutions, which is it's an actual pre-built offering that's curated and offered by Microsoft, just so you're aware, that is something that is completely different than what we're showing here. We're showing the CMS Medicare Part D data, and the healthcare data solutions, or sometimes you'll see the acronym HDS. That's completely different, and they have a solution for ingesting CMS Medicare claims data, I believe it is, which has nothing at all to do with what we're showing today. So we did want to call that out quickly. What we're showing today was created by Inder and I to be completely open source and free for the purposes of primarily for the purposes of training and also testing, and then for people who need demos in a Fabric environment. It's not intended to be a production solution. The data itself it's real data from CMS. If you want to build a production solution with it, that's on you, but that's not the intent of what we're doing here today. So Inder has kicked off his pipeline. So I'm going to quickly just move back to my workspace here. And what I'm going to show is an alternative to what Inder is showing. If you go back to the repo itself, which I'll show here, we have option 2A and option 2B. And this was something that I think actually comes down to the skill sets that Inder and I have, and how we have a slightly different perspective on how we like to build things. I do think we made Inder's 2A because that is more in line with the long-term, what I would call industry kind of gravity and where things are going, which is to use Python and PySpark and notebooks and do everything from that perspective. However, I like to say that I'm SFL, SQL is my first language, so I prefer having the data in a warehouse. And we also discovered that the Fabric warehouse is extremely powerful. So if you go with option 2B and use the stored procedures, which are in the repo, they actually run faster than the Spark notebooks. And we double checked with the product group. And in some scenarios, the warehouse can actually be faster than those Spark nodes. So it's a very powerful tool. And for those of you who come from a SQL background, it's built for you. So if I were to come back up here to the top and effectively go into scripts, you'll see that we have our two SQL stored procedures. If I were to click on one, you'll see it's doing the same activities as what Inder's notebooks were doing in Spark, which is to effectively create the four tables and then populate them with data from that giant flattened table of data that's sitting in the silver layer of the lakehouse. So effectively, you're then creating a warehouse, which can be used as if it were a SQL server. So I'm going to quickly move back to my environment and show an example of that. If I go ahead and click on this data pipeline, you'll see that we have the action items in the pipeline for stored procedures. And if I were to go to settings, it's calling a stored procedure, which is stored in the Fabric warehouse. So you can see that down here is where you deploy the stored procedures. All of the instructions on how to do that are in the repo. And this will actually populate the dimensions from the queries that hit that silver layer of the lakehouse. Then after those are populated, it will create the fact table. The reason being is that the fact table will actually use the dimensions key values when creating the fact table, so that all you have on the fact table is things that should be aggregated or that are being used as foreign keys. And your primary keys that are effectively surrogate keys are on those dimension tables. So again, alternate version of the same solution. And I want to note here too, what this might also be good for is if you want to do some testing of direct lake mode against the lakehouse, or using the SQL endpoint against the lakehouse versus doing that with the warehouse. It gives you the ability to maybe benchmark how the queries might be slightly different between the two. Both are extremely fast and highly performant, but they're there for you to test and use. If I move over to the warehouse, you'll see that we're now looking at a very SQL-ish experience. I can go ahead and run a query against that data. And I think somebody might need to mute. I'm getting some feedback there. But effectively, you can start running queries. You can deploy views. You can build additional stored procedures, call these things from pipelines. And at this point, it's a very SQL-esque experience. Even if I were to open up SQL Server Management Studio using my identity and the SQL endpoint, I could also connect to that Fabric warehouse and start running queries against it from SSMS as if it were a SQL server. So I'll just go ahead and let that open up real quick. And real quick, are we going to 11:45 or 12? I just want to make sure I pace myself correctly. Okay, well, I'll try to get done here in the next 10 minutes or so.
I was on mute. We have 30 more minutes. We're good until 1 Eastern.
Okay. Sounds good. Yeah, just wanted to make sure that I didn't need to cut out some content here. So if I were to hit connect, this will take me to my Microsoft environment. It'll say my authentication is complete. I can then move back to SSMS, and it'll make a connection to a lakehouse. And at this point, I can either connect to a lakehouse or my warehouse. And, then we're back in SQL world, which is my comfort zone. And it's where I prefer to do exploration and try things out. I am, skilling up on Python and Spark notebooks, but this is still kind of what I grew up in. And I'm very happy that this is going to be here for the long term with Fabric. So moving back to my environment here. So we now have this star schema in the warehouse. And from here, I go back to the repo, and I'm going to go back up to the next level up. We've now gone through step 2A or 2B. I'd say and, so you can try both of them out. And then step 3 does still require some manual work. We're waiting on some new capabilities so that we can perhaps deploy a BIM file that you can use Tabular Editor to deploy the semantic model with. It's just not fully supported yet with direct lake models. But this walks you through the process to build the semantic model. Everything's cut and paste. So if you don't write DAX or you haven't done this before, it's very descriptive and it should help walk you through the process. But effectively, you have one fact table with 4 dimension tables. Do be very deliberate with the naming conventions for these columns and make sure you follow the instructions because when you deploy the Power BI report, the naming conventions will need to match in order for everything to work without errors. It walks through the different measures that are built into the semantic model. And, again, there's a lot more you could do with this if you want to add more to it after you've deployed it. And then also there's some metadata changes to indicate, geography columns, and, different types of data types and whatnot in order to make everything work the way that it should work. And also I will note that Power BI Copilot will then work directly on top of the semantic model. So having good, solid, natural language titles to everything will help Power BI Copilot work even better than if it were looking at something such as PRSC, RBR, city state. It might interpret that city state, but prescriber city state is going to be a little bit easier to read, both for the end users and for Copilot when it's using natural language to run queries and perform its duties. So then down at the bottom, kind of walks you through how to go ahead and deploy everything. If I move back up here to the top again, once you've built out that semantic model, which I'll show, we then also have a Power BI PBIX file, which you can open up. And I need to add some notes. When you open it up, it'll say, lakehouse or warehouse not found or semantic model not found. You just need to hit edit and then redirect it to the one that you have permission to view that has been created with all of the instructions in the repo. So if I were to go back to my workspace, and I'll go ahead and open this up here, but here's the semantic model, which was built on top of the warehouse. So let's go ahead and open that up. And you'll see here that in this semantic model, everything was put together using the instructions in that repo. And then you have your calculations such as cost per claim, where you divide the total drug cost by the total claims. You can see that the formatting is set to currency so that it shows up looking like dollar values, things that are not needed in the end report. And this is a good tip for Copilot in general, is if you don't need something in a report, make sure that you hide it, because otherwise Copilot will see it and it might bring it into the results when there really isn't a reason to do so. So by curating and limiting the information that you make available in the semantic model, not only will it make it more readable for your end users, but it will also make it more readable for Copilot so that you'll get better results. So if I now go back to the workspace, I'll show the report, which was deployed from that Git repo on top of that semantic model. I'll go ahead and open that up. You can see we're in direct lake mode, and we have 249 million rows at the source. If I were to click on the year 2022, it'll filter everything down to 26 million rows. Maybe I move over here and switch over to the state of Alaska, which I like to choose because it's at the top of the list. It'll filter for that particular state. And then I can drill into physician assistant and get the details. And you'll see we have real physician assistants from the real world in the year 2022 from Alaska. You can look at their total drug cost, cost per day, total claims, cost per claim, what drugs they're prescribing, and even click on an individual in order to filter the table down at the bottom. So if you're in consulting or you're doing demos or evaluating products, within a couple hours, you can have all of this up and running so that you can go show your stakeholders what these tools can do. And it also gives you an environment where you can go load test it and say, hey, you know what? This isn't just a smoke and mirrors demo that Microsoft put on a video. This is real data, and I can go push it to the limit and see what it can or can't do. Additionally, if I were to move back to the home page, it's already now pre-configured to work with Power BI Copilot. So if I were to say, give me an executive summary, it'll reach out to Copilot, use the data from the screen. And to note, it has also been filtered for Alaska and the year 2022. So the answer will be in the context of those answers. And it'll basically give you a summary of what's going on with the page. And I could maybe say, show cost, show a scatter chart, cost per day and claims per day. And make sure I spell it right. By state. And then it will, in the preview version of Copilot, will actually create visuals too that you could even add to a page if you were in edit mode. So we'll just wait for that to generate real quick. And effectively now you're able to chat on top of your data, and you can even ask it questions. There we go. So now I could expand that view, and there'd be a button down here to add it to the screen. If I was in edit mode, you can even hover over things. And I even asked it a question yesterday, such as, does Power BI support BIM models when using direct mode? And a BIM model is a business intelligence model. It's a way to use Tabular Editor or Visual Studio or some data tools, something like that, to go create a version of your tabular model and redeploy it somewhere else, which is what we're eventually going to do in order to. It says it does support it. So I think that might be the wrong answer, but we'll have to double check. Maybe things have changed. But if I go ahead and move back now to my workspace, one moment here. I'm going to open up the AI skills demo, and this is something that we'll be adding to the repo within the next week or two. So stay tuned and please follow up here. But AI skills is giving you the ability to use large language models on top of your data that's in Fabric. So I'm going to quickly show what this is doing here. So we have our 5 tables from the star schema available here from the warehouse. But in addition to that, some additional notes have been added here. So for example, if I go ahead and move over here, again, it's still a work in progress, but you can see here, here's the notes. It's saying the data is from the CMS Medicare Part D prescribers by provider and public database. It walks through what the different columns do and what they could be named or what synonyms might be. It goes through some of the different columns that are to be aggregated. And what's interesting here too is I found that it works if you add additional information, such as that all ACE inhibitor drugs contain Pril in the generic name, or all quinolones contain fluoxetine in the generic name. So you can start adding data that's not in that source data so that it can be available when you're doing these large language model queries. Additionally, if I were to open up some example SQL queries, I'll just walk through the first one. This is how you would want to see show cost per day of ACE inhibitors in the state of Florida for internists in the year 2020. And you'll see it's selecting the generic name, doing the division, accounting for when things are 0, and then it's doing the joins to the other tables, and it's giving the where clauses, such as the generic name contains Pril if you're dealing with an ACE inhibitor, and then the state name, and because it was internists, it's looking for internal medicine. So then when you have that information in there, you can come in and say, show total cost for internists in Texas for 2019. We'll do top 10 internists in Texas for 2019 when prescribing quinolones. And I think I spelled that right. Yep. So if I put an A there, I think I'll get spell checked. Correct. Quinolones, I'll go ahead and hit go. And I won't spend a lot of time here, but you can see where I'm going with this. And I don't have access to what the product group is doing, but I've been told there's a lot of investment in this particular tool, and that it's something that'll be a very important part of the roadmap moving forward, just based on what I've been told. Again, I'm not the source of truth on that matter. But you can see now we have the actual doctors with their prescriber type. They're all internists, and the total cost. And maybe we want to, change that query a little bit and get a little bit of a different answer. And down here, you can even double check the code if you'd like. You can see I have that toggle turned on to make sure it's calculating things correctly. So maybe let's change it to 2021, change internists to doctors, and maybe change this to ACE inhibitors. Right? And then it'll use the information that you provided as examples, and it will understand how to substitute the different scenarios, and even give you additional information such as let's say show a list of states with a new column for the 50 USA states versus other values, right? So you can even do, queries on top of the underlying dimensional tables and get some of that descriptive information that might even be used for other purposes. So here you can say it knows the Virgin Islands is others, DC is other, and then you have your 50 states, and it's actually creating some new information. And I think it's really cool that you then get a SQL statement that does all of that for you. So again, this will be available in the next week or two. Everything else already is available, and all of this should be something that you can deploy from the source at CMS to the lakehouse, bronze, silver, gold, also a warehouse gold layer as an alternate version with your Power BI report and your Copilot capabilities, all in about maybe 2 or 3 hours the first time you do it, and less time than that once you've done it before. So I'll go ahead and pass the baton back to Inder, but we can also make sure we, save enough time for questions here at the end.
Thanks, Greg. Yep, we were just on time. So the pipeline which we kicked off, I'm in the central time zone. So we kicked off around 11:20. It just completed like a few minutes ago. So we have the successful execution of the pipeline. And if I go back here, we have the data available. If I go to, this is just a lake house I opened up. This was populated by that pipeline we just executed. Instead of seeing over here, the lake house comes through the SQL Analytics endpoint. So we do write with Spark, but if your preference is SQL, you can still read data from a lake house using the SQL Analytics endpoint. So I'm just switching to that view, and if I expand this table, so if you look at it, so these are the columns. I can say select count star from CMS, and let's go provider underscore drug underscore cost star. You can run this query. The meantime, while this is executing, it is 249 million rows. I can run another query over here. Total drug cost by year and state. So in about 42 minutes since we started, we were able to build out the build out this lake house. So build out the pipeline, the notebook import, and we have the data available. Then the subsequent steps, you can try out the option B where you build out the warehouse or build out the semantic model and reports. So you should be pretty easily be able to set it up within 1 to 2 hours. That's all I have. So good to see that this report, this pipeline completed within time. We are open to any questions you might have at this point. All right, if nothing else, I think time for lunch for us. I'm in the central time zone, just before 12.
Awesome. Thank you both. This was awesome.
Thanks. Bye.
Bye, everyone.
Thank you.
Thank you. Bye.